Hello everyone, welcome back to my Sling build log. This is the big one. The wings go on up to the airplane. There are 8 bolts per wing and they do not want to go in. This is a longer video than usual because I want to take you through the whole thing. All the prep work I did, the mounting process itself, and all the work after that. Let's get into it. First, I needed a way to hold the wing. A fellow builder from the Faithful Building Group gave me an idea to build a rolling cradle so the wing lies flat and I can wheel it up to the fuselage. It's pretty simple. 2x4s, deck screws, and a wool mat on top, and 4 trailer jacks with wheels, one at each corner. All 4 are height adjustable, so I can wiggle the wings up and down when I line it up with the fuselage. The two ends aren't the same height. The root end is wider because of the wing taper, and it sits lower than the tip end because of the wing's dihedral, the upward angle the wing sits at. I sketched it out against a dihedral number from the POH. The wing half span works out to be about 4,000 millimeters, and the dihedral is about 5 degrees. So over the 8 feet of the cradle, that comes to about 210 millimeters of difference between the two legs and between the low legs and the high legs. So on my drawing, one leg is height x and the other is x plus 210. And I measured the value x in the field next to my airplane. The rest is just labor. It was about 90 degrees out in San Martin, so I took it slow. The wheels were heavier than expected. I spent about 15 minutes each to bolt them on, then carpet on top and a strap on each end to hold the wing down. One more thing before any wing goes on, bullets, aka tapered pins. A bullet is just a sacrificial AN7 bolt that I grounded down thinner and tapered on the bench grinder. Because it's skinnier than a real bolt, it slides into the spar holes easily and pulls everything into line. I use it to hold the holes lined up, put the real bolts right behind it, and punch the bullet out. There is no precision to it. I just kept using the bolt against the grinder until it tapered, and stopped whenever it goes too hot to hold. While the wings were still off, I wanted to knock out everything that goes harder once they are on and the cockpit is tight. First, the passenger seats. They're bulky and much easier to carry in when no wing is in the way. So the catch with the seats were that the seatbelt's anchor bolt. The belt has to thread through a slot in the seat, which means taking the anchor bolt out, feeding the belt through, and then putting the bolt back. The left side wasn't bad. The right side sits right behind the parachute rocket box. It's basically hidden, and I could barely get a hand on it. Getting that one bolt out and back in was about 90% of the whole job. I can't wait to do that again at the annual. Then the big rear leather side panels. The pilot side mostly lined up. The co-pilot side fought me. The ELT antenna behind it was holding the panel off the skin, so I had to cut a notch around the antenna and had to grind a few screw holes to get them to line up. Once the panel was on, the 2-inch holes I cut a month ago lined up perfectly for the air vent. So I finally snapped in the rear air vents, and those just clips onto the wall. I also closed up the center channel over the rear row. It's mostly trivial work, but it took a lot of little tweaks. So I had to do reaming, shaving materials, trimming carpet to get the whole run of cover plates to sit down and the M4 screws to tighten. I'll have to open it back up in a few weeks to route the parachute cables, but for now I want it to close so it's out of the way and gives me something solid to lean on while I'm climbing around mounting wings. The one slightly involved part was the USB power for the passengers. So the wire are labeled as AFR48, which is a white and a white-blue strand. The diagram says the white-blue is positive and white is negative, and I checked that with a with a multimeter before I committed, and then crimped them to the USB plug. Last thing here, I needed to get the fuel pump wires from the cockpit side out to the wing side, and all the existing holes were already spoken for, so I cut a new one between the fuel inlet and the return lines. A quarter-inch pilot hole opened it to a half-inch, then a small hole punch to size it, and a rubber grommet so the wires doesn't chafe on the edge. There are a lot of rod ends for the control surfaces. Aileron and control stick rod ends, bell crank rod ends, flap rod ends. I wanted them all in before the winds closed up that space. Most of them took 5 or 10 minutes each, and they went fine. And then inside the cockpit, there are the 2 rod ends directly under the main spar for the aileron connection. Those took me about 3 hours. The space is tiny. You had to line up a bolt, a stack of washers, the rod end, and the more washers, and the nut, all in one line, in a spot you can barely see, and then find some angle to get a torque wrench onto the end for bolt. The trick that saved me was contact cement. I glued the washers into a stack so they'd stay together and stay stuck to the spar while I feed everything in. Otherwise, the washer just falls away where you can't reach them. After a couple hours and almost throwing my back out, I got both of them on and torqued. I also marked the length of the flap torque tube and test fit the connecting rod and the flaps, so I know how far the tube sticks out on the wing root. That's what sets where the locking collar goes later. Now, finally, mounting time. We started with the right wing. My wife E, and my friends Kevin, Brian, Kelly all came to help. We put the wing on a cradle and then pushed the airplane out of the hangar for room. Then we wheeled everything back in together and started lining it up. Alignment is the whole game before any bolt goes in. By adjusting each cradle's leg height, we got all 8 holes on the main spar to line up between the wing and the fuselage carry-through. I put a bullet through the one hole to hold the alignment and used the punch to hold the rear spar in its AN5 hole. And before we went any further, I made sure the flap torque tube locking collar was in, because once the wing is on, you can't get to it anymore. Then the bolts. 8 AN7 bolts through the main spar, and they are an extreme tight fit. There is no pushing these in by hand. I started with a rubber mallet, which was useless, was way too soft. I went to a 3-pound hammer. That drove the top center bolt just fine, but the bottom center one had the awkward spacing, and I couldn't get a full swing at it. So I switched to a air rivet gun, and right as I set it up, my air compressor died. My hangar friend Brian lent me his, and I was back in business. The rivet gun tapped a few more bolts through, but even with it, they were hard. I kept switching between the hammer and the gun, and as soon as bolt cleared the far side of the hole, I'd stop tapping, spin an AN7 nut onto the thread, and use the nut to pull it the rest of the way through. The 5th bolt got me stuck. It's on the bottom row, tied to the skin, and my rivet gun was too long to sit square on it. It sat at an angle, so the force wasn't going straight into the bolt. No matter how hard I went, it stopped halfway. Kelly came to the rescue with a shorter gun. It's really more of an air hammer than a rivet gun, but that lays flat and points right at the bolt. I tried his, and with barely any effort, it tapped straight through. So 4 hours, 5 of the 8 bolts are in. No torque yet. That came later. The last 3 bolts I did a couple days later, And this time I tried some dry ice. I picked up 4 pounds of it from Safeway, and I greased each bolt, put put them individually in its own Ziploc bag, and then sand it on the dry ice for 3 to 5 minutes right before I needed it. I only chilled each one just a few minutes because I didn't want to leave them on there too long and therefore get a potential thermal shock. I just wanted them to shrink a little. Even a few minutes seemed to help. They felt easier to drive. Same routine as before. Hammer, tap, pull through with a nut. The last three went in a little under 2 hours. Then the left wing was the big day. Instead of three people around the wing, I had about 10. Hangar neighbors and friends from my EAA chapter, Jason, my EAA tech counselor, and Edward all watched the alignment. Everyone else wiggled the wing while I drove the bullet and then the rear bolts. As I moved from bolt to bolt, I kept the next one sitting in dry ice, about 5 minutes to chill on each. And the crowd made a huge difference. On the right wing, it took us 4 hours to get 5 bolts in, but this time we started about 10, and by quarter to 12, we had 7 of the 8 in, driven far enough that the threads were cleared of the spar and just a millimeter to left to pull. At that point, my helpers were done, and I drove the last bolt along. It's the lower left corner, tight to the skin and hard to get any tools onto. I got it about halfway with brute force, then finished it with a rivet gun once there were enough room. Then I pulled every bolt fully through with an AN7 nut, took the nut off, and put on the washer and the lock nut. Just snug enough to feel the friction come up. No torque yet. That's next session. With all 8 bolts through on each wing, they get torqued. Every AN7 main-spar bolt goes to 55 Newton meters, and the AN5 rear bolt goes to 18 Newton meters. Most of them were straightforward. The one exception is the bolt tucked right into the fuselage skin corner. There's no room for a normal socket there, so I used a crawl foot to reach it. A lot of this is underneath the airplane, on your back. So my friend Brian gave me a spare creeper to roll around under the belly, which is a lot better than lying on the concrete. I did the right wing first, then the left wing the same way a week later. Then there comes a group of smaller tasks on each wing. The wing walk strips first. They're not structural, but they're easy and they protect the wing. So I dry fit them, cleaned the surface with acetone and 99% alcohol, and then stuck them down. Next, the OAT sensor, outside air temperature sensor. The harness already has a spot to plug it in, so I tested the wiring, drilled a small hole in the wing, and tightened the probe through it. Then the wing harness connector. It bolts to the fuselage with 4 and 4 screws. The holes don't want to line up at all once, so I put a long screws in first to pull everything into position. Then I swap them for the right length screws one at a time. The pneumatic lines from the pitot tube just pass through 2 grommet holes. Then the harness itself is long, so I bundled with zip ties and added edge protectors anywhere it runs near a sharp wing rib so it can chafe. Then comes the flaps. The flaps are the fiddly part. Installing the flap itself isn't bad. 3 bolts and a stack of thin washers. A little bulky but straightforward. The work is in the locking collar. Each flap has 2. So there's a smaller collar that rivets in near the wing root, right next to the torque tube's bushing, to stop the tube from wiggling around. Drilling that hole after the wing is already on was brutal on the right side. So for the left wing, I learned my lesson. I pre-aligned the tubes and pre-drilled that hole before the wing went on. So all I had to do afterwards was riveting it. Even just riveting it by hand in that space was rough, but it beats drilling. Then there's the long collar that connects the flaps on torque tube to the flap motor tube. I measure the collar and then find the center, then set it evenly across the two tubes. Then I mark and drill 4 holes for A and 3 bolts. While I do that, I put a gas lock on the flap to hold it at 0 degrees, so the tubes are sitting in their real position. Then I torque the 4 bolts, power up the avionics, and run the flaps up and down, make sure both sides move smoothly with no binding, and they did. Okay, a couple of loose ends to finish. There's a fuel sender wire pre-built into the harness. It's labeled EIS 7B on my harness on the right wing and EIS 6B on the left. It's a 3-stranded wire, but I only need the one signal wire. Adam at Midwest Panel Builders confirmed it's the white-blue one. So I stripped that and crimped the blade contact connector to it, then left it unconnected for now. I don't want it in the way while I was working on the fuel line later. After that, cleaning up. With the wings on, I took down the vertical cradle I'd be storing them. I kept the mounting cradle though. I'm helping my friend Kevin mount his wing in a few weeks. That opened up enough to walk around the nose and push the airplane in and out without hitting anything. I also finally put in the seat rails. I built those almost 2 years ago, but never installed them because they'd have blocked the torquing wrench on the top wing bolts. I test fit a front seat and hit one snag. The right side latch doesn't fully retract when I pull the adjustment tab, so the seat won't slide freely. That one needs the latch grounded down a couple millimeters, which is a job for later. But the headline is both wings are on and torqued. Next up is the final flap and aileron torquing, the fuel lines, and everything that comes with finally having a full airframe. Thanks for watching, and I'll see you in the next one.